Hi, I'm Manu G from 6M SVC. I'm gonna take the topic mutation analysis and fault-based adequacy criteria. What is mutation analysis? Mutation analysis is a powerful technique used in software testing to evaluate effectiveness of test suites. It could involve introducing small changes known as mutations into the code under test, then rerunning the test suite. The mutations are designed to simulate faults in the code, and the goal of the analysis is to determine how well the test suite is able to detect these faults. Mutation analysis in fault-based testing. Fault-based testing is a technique used to design test cases that are specifically targeted at detecting faults in the code. Mutation analysis is a natural fit for fault-based testing because it allows us to simulate these faults and evaluate the effectiveness of the test suite in detecting them. By introducing mutations into the code, we can evaluate how well the test suite is able to distinguish between correct and incorrect behavior. Benefits in mutation analysis. Mutation analysis has several benefits for fault-based testing which includes it provides a rigorous evaluation of effectiveness of the test suite in detecting faults. It can help identify gaps in test suites that need to be addressed to improve fault detection. It can help prioritize test cases based on their effectiveness in detecting faults. It can help reduce the cost of testing identifying redundant or ineffective test cases. What is the fault-based adequacy criteria? Fault-based adequacy criteria are used in software testing to evaluate the effectiveness of test suites in detecting faults. The idea behind these criteria is to design test cases that are likely to reveal faults in the code based on understanding of common types of faults and the code structure. Statement coverage. These criteria requires that each statement in the code is executed at least once during the test suite. This is simple and widely used criteria, but it may not be sufficient to detect all faults. Branch coverage. This criteria requires that each branch in code is executed at least once during the test suite. It is more comprehensive than statement coverage, but it may still not be sufficient to detect all the faults. Condition coverage. This criteria requires that each Boolean condition in the code is evaluated to both true and false at least once during the test suite. It is comprehensive than branch coverage, but it may still not be sufficient to detect all faults. Multiple condition coverage. This criteria requires that each combination of Boolean conditions in the code is evaluated at least once during the test suite. It is more comprehensive than condition coverage, but it may be difficult to achieve in practice. Path coverage. This criteria requires that each possible path through the code is executed at least once during the test suite. It is the most comprehensive criteria, but it may be very difficult to achieve in practice for complex code. I hereby conclude, while each criteria has its strengths and limitations, using a combination of criteria can help ensure a high level of fault detection and minimize the risk of software failure. And hereby end my session. Thank you.